Hello and welcome back to my YouTube channel Electrical Hub. Here we are going to discuss about the technical and commercial losses of distribution transformer. We will cover some of the points to know exactly about the technical and commercial losses of distribution transformer. The topics that are to be covered in these sections are basics of transformer, second, voltage regulation of transformer, how to calculate rating of the transformer losses, parallel operation of transformer standard and leveling of transformer distribution losses and optimization of transformer, causes of technical losses and measures to reduce the technical losses, commercial losses, computation of technical and commercial losses, finally the billing efficiency. First, let us start with the basic of transformer. Transformer transfers the power from one source to the other by mutual induction without change in the frequency. Basically, transformer is used either for the stepping up of the voltage or stepping down the voltage, but sometimes it is also used for the change of vector configuration. For example, from DYN11 to DYN1 or anything like that, or from delta to star like that. Working principle of the transformer. It works on the basis of Faraday's laws of electromagnetic induction. Now, what is the voltage regulation of the transformer? Voltage regulation of the transformer is a change in the voltage from full load to the no load of the transformer. Now, the rating of the transformer for the power or the distribution transformer, the rating of the transformer is calculated on the basis of the connected load and diversity factor. Connected load means from the source where you are taking the load or what amount of load you are going to take from a source. And the diversity factor is the overall maximum demand of the plant by sum of the individual maximum demand of equipment. Diversity factor is always less than 1. Now, let us discuss about the losses of the transformer. First, distribution loss. Transformers are basically connected to distribute the power to a section. So, it should be located close to the connected load to minimize the losses due to the voltage drop. Because as the voltage will drop, the current will increase and the I square R losses in the line will also increase. There are basically two types of losses in the transformer. One is the no load loss and the other is the load loss. No load loss also known as the core losses. It occurs whenever the transformer is energized. It does not vary with the load. Core losses are caused by two factors. One is the hysteresis and eddy current loss. Hysteresis loss: energy lost by reversing the magnetic field in the core as the magnetizing current AC rises and falls and reverses the direction, while the eddy current loss is a result of induced current in the circulating core. And load loss: power lost in the primary and the secondary of the transformer due to the ohmic resistance of the winding is known as the load loss of the transformer. Copper loss varies with the square of the current. So power loss is equal to I square R. So finally, the total losses of the transformer is equal to power at the no load plus percentage of load divided by 100 multiplied by power at the load. And where the loading of the transformer is known is equal to no load loss plus kVA load by rated kVA squared into full load loss. Parallel operation of transformer. Parallel operation of transformer reduces the losses of the transformer and increases its life. It is also important in stabilizing the load, but there are some few important points to be considered while operating the transformer in parallel. First, there should be a same phase angle between the primary and the secondary terminals. Second, same voltage ratio. Third, same percentage impedance. Fourth, same polarity. And fifth, same phase sequence. The important thing is that if we do not have these conditions, then there is a possibility of circulating current in the transformer which can cause a huge loss and maybe damage to the transformer. Energy efficient transformer. Energy loss in the transformer occur mainly due to the heat or vibration from the core. Iron loss in transformer depend upon the type of the core, and previously the cores are made up of silicon alloyed grain oriented core, but now amorphous material, a metallic alloy is used, which reduces the loss by 70%. It is important to note that before 2010, there was no standardization and labeling of distribution transformer. But from 7th January 2010 onwards, BEE Bureau of Energy Efficiency has included distribution transformer under standard and the labeling program. Now, the existing efficiency or loss standard are specified in IS 1180 at 50% or 100% load. So, as the distribution transformer is labeled under the efficiency standard of BEE, we should also consider some measures to reduce the losses of distribution transformer. Some of them are relocating transformer near load centers. Second, is a power factor improvement. Third, opting for low resistance AAAC or aluminum alloy conductors, minimizing losses by removing the old brittle conductors. Now, let us discuss about some causes of technical losses of distribution transformer. First, a lengthy distribution line. Either 11 kV or 450 volt line is stretched for a longer distance in the rural areas, which causes a huge line losses. Then, inadequate size of conductors. On account of load growth, many distribution feeders end up being undersized. So, it causes a heat loss. Number third is the improper voltage regulation. That is, the voltage drop in the line is higher due to the long distance, inadequate size of the conductors. And the fourth is DT not located near the load centers. If the transformer is not located near the load centers, then the lines used to be longer and it add to the loss of the distribution transformer. Low power factor. Low power factor is also one of the major cause of technical losses in the distribution transformer. Now let us discuss few measures to reduce technical losses of distribution transformer. First is amorphous core transformer. Amorphous core transformer reduces the loss of the transformer by 70% compared to the silicon alloyed iron grain oriented core transformer. Secondly, high voltage distribution line. We should maximize the distribution line with the high voltage. It will reduce the I square R loss in the line because the current will be reduced. Thirdly, location of the transformer near the load center. If the transformer will be located very close to the load centers, the losses in the line occurring due to the heat will be reduced. It can also be reduced by improving the power factor. So, if you are not aware of the power factor improvement and its benefit, I will give a link in the description box. So, kindly go and see about the power factor improvement and its benefits. Commercial losses of distribution transfer. There are a few causes for the commercial losses of distribution transformer. Let us discuss one by one. First, discrepancy in the meter rating. At some flat or some building, some houses are locked for some time. So when the person come to take the meter reading, he cannot get the accurate reading. So it causes a commercial loss. Secondly, illegal consumption. Mostly in the rural areas, some people used to tap the line and take the power for the home or for the shops. It is under the illegal consumption of power which causes a losses commercially. Then meter tampering. Before we are not using the electronic meter. So a lot of cases were found of meter tampering, which causes the commercial loss of distribution transformer. Computation of technical and commercial losses of the transformer. So total technical and commercial loss of the transformer is equal to 1 minus billing efficiency into collection efficiency into 100. Billing efficiency is equal to total units sold by total input into 100, and collection efficiency is equal to revenue collected by amount billed into 100. Share and subscribe my YouTube channel. I will be also thankful if you put your valuable comments or important suggestions. Thank you.